Alright, we're looking at Objective GCO9. This video deals with Worksheet 1 and Worksheet 2. The first thing we're going to do is define a bunch of maybe new geometric terms to you. The first one is adjacent angles. Now, let me just draw two adjacent angles, and the visual might help us out a little bit here. Angle 1 here and angle 2 are adjacent. Now what makes them adjacent is, first of all, that they must share a vertex. The second thing they must do is they must share a ray, and they do. Notice they share this ray here. And then also they must not share any interior points. So in other words, they cannot be overlapping each other in any way. They share this vertex, they share this ray, and everything inside of in the interior of 1 is over here, everything in the interior of 2 is over here. Why they make this statement is that there might be some confusion if I say angle 1 is this angle here, and angle 2 is this one. Now, if it's the big angle here, they would share the same vertex, angle 1, the shaded angle, and the big one. They would share this ray over here, so it would also be good. But because they overlap, angle 2, the big angle, and the little one, they would not be called adjacent. Adjacent must be basically side by side. The next guy is called a linear pair. Now the reason why we defined adjacent is because adjacent gets used in this definition. A linear pair are adjacent angles that sum to 180 degrees. Now this phrase can be substituted for another geometric word. It's our next one, so I'm going to substitute it now. Supplementary is the word for angles that sum to 180. So we're looking for adjacent angles that are supplements or add to 180. These guys all look like this. They form a straight line, thus a lines pair. 1 and 2 are adjacent, they share this ray, they share this vertex, and they do not overlap, and they sum to 180, so they're supplements. So supplement angles, or supplementary angles, are angles that sum to 180 degrees. Now that can look like a linear pair. Linear pairs obviously add up to 180 because they form a line. Or they could just be angles that, let's say this is 50 and let's say this is 130. These are also supplements because together they make 180 degrees. They do not have to be a linear pair. They do not have to be adjacent. They can be separated. All linear pairs are supplement angles though, because they all add to 180. Complement is angles that sum to 90. So angles that sum to 90, we've seen this right angle symbol here. If this is angle 1 and 2, they are complements because together they add to 90. Now these two phrases often these two terms get mixed up, and so let me see if I can help you out. Complement, C, comes before S, and 90 comes before 180. So complement is 90, supplement is 180. The final definition or description of an angle or pair of angles is a vertical set of angles. Vertical angles are non-adjacent, there's that term again, non-adjacent angles that are formed when two lines or segments intersect. So let's take a look at our picture where the two that are non-adjacent when these lines intersect. So 1 and 3 would be known as a pair of vertical angles. And 2 and 4 would also be known as a pair of vertical angles. Now this objective actually wants us to prove certain things to be true about angles and about sides and segments and things like that. The first thing we're going to attempt to prove is that vertical angles are equal. And when you look at them, it sure looks like angle 1 is the same as angle 3. So we're going to prove that right now. And we'll do it in two different ways. I'm going to use kind of a transformation approach, and then we'll use kind of more an algebraic approach. Let me give you the big idea first. I'm going to establish that this angle here, if it gets rotated 180 degrees, will basically land right here and be equal to its vertical angle. That's the big idea. So let's describe what we think and why we think it. So, if we rotate about point E 180 degrees, a rotation about E 180 degrees, we map point B onto the opposite ray ED. In other words, by definition of 180 degrees, when we defined it to be, if you rotate something 180 degrees, it will be on the opposite ray that it is currently on, and so that would be on this one. And it would also be true that that same thing would map point C onto ray EA. So B would get mapped somewhere equidistant on the opposite ray. C would get mapped on its opposite ray in equal distance. And now we notice something. That angle B prime E C prime is actually the same angle as DEA, because they have the same vertex and rays. Now, due to the fact that rotations are isometric, we would know that angle BEC, the original angle BEC, has to always be equal to its image. So we would know that BEC equals B prime E prime C prime. And then using a transitive argument, angle DEA would be congruent to angle BEC. Now, what does a transitive argument mean? Well, basically it means to link things that are identical, congruent, or equal. So let me show you what I mean by that. BEC was congruent to B prime E prime C prime. And earlier we established that B prime E prime C prime was equal to DEA. So using that connectivity, that transitive property, we're able to establish that they are equal to each other. Let's do it in a little bit different way now. This is more of an algebraic way, and I'm going to use it in kind of what they sometimes call is a two-column proof. So I'm going to list my statements over here, and I'm going to give my reasons over here. Up above, we did kind of what was a paragraph proof, basically describing and explaining as we go in terms of prose or writing. And now here we're going to organize it in a little bit of a column technique. So here's what some students might approach. They might say, you know what, 1 and 2, angles 1 and 2 equal 180. Definition of a linear pair. In other words, a linear pair are adjacent angles that form 180 degrees. It would also be true that angle 2 and angle 3 would equal 180 degrees, also based off the definition of a linear pair. So 2 and 3 are equal. Now notice they both equal 180, and so I can make a substitution and say 1 and 2 now equal, and I can substitute in there 2 and 3. Substitution property, okay, of equality. Now I notice that I can knock off angle 2, right? I can subtract angle 2 from both sides. We have a rule that is the addition-subtraction property of equality that says you can always subtract equal things from both sides. And then finally, it would be true that angle 1 and angle 3 are congruent because they have equal measures. So here's a different way of establishing it, and a fairly more, maybe for some, logical or organized. Both being perfectly fine. Let's finish up here just to show you how we might use some of this information. Well, we have now proven that all vertical angles are equal. So I know angle 2 has to be 41 degrees because it's a vertical angle to 41. I actually also know that this has to be 139 degrees because, so I knew this because of the vertical angles. I knew this because of the linear pair. Remember, linear pairs add to 180. 139 and 41 makes 180. Here I could say that 3x plus 18 equals 96. They are vertically opposite, a vertical pair, so they are equal in size. 3x equals, let's see, 78, and x equals 26. Here also I know that this equals this because they're vertically opposite. We prove that vertical angles are equal, and so I can solve this here. X equals 40. They also want to know the size of CAB. And so the size of CAB would be x, which is 40, plus 40, so it equals 80 degrees. Vertical angles are equal to each other.